Across the world, people are exploring ways to create more sustainable power solutions for our planet. We already know that nuclear power presents a reliable source of clean energy. Many countries have run successful nuclear programs for several decades, using uranium to fuel their reactors. As a natural element taken from the Earth's crust, uranium is both available and, when used in energy production, generates far less carbon emissions than fossil fuels, working alongside renewable solutions like wind and solar to produce a consistent energy source. When irradiated, uranium becomes unstable and splits into smaller atoms through a highly exothermic process called fission. This releases neutrons, which go on to collide with other uranium nuclei, causing a chain reaction. It's the heat from this process that's harnessed to generate electricity. Over time, due to a buildup of fission products which absorb the neutrons, the fuel becomes less efficient. At this point, it's replaced with a fresh supply to keep the power plant operational. When removed from the reactor, the old fuel is thermally hot and highly radioactive. To cool it down and reduce the level of radioactivity, it's placed in water for at least 5 years. Eventually, it's removed and processed for burial deep underground. Many countries with nuclear programs have adopted an open fuel cycle. This means fuel is only used once in the reactor before being disposed of. Yet the fission products account for just 4% of the used fuel, with the rest made up of material still fit for purpose. Researchers are now looking at effective methods to recycle the fuel, with scientists and engineers exploring improved ways to separate the useful materials from the fission products, creating new fuel that can be put back into a nuclear reactor and used again. That's a greater, more sustainable energy source than before. One method for separating the fuel elements is called pyrochemical processing, also known as pyro-processing, which takes advantage of the properties of liquid salt to allow the removal of the fission products from the used fuel. A mixture of lithium and potassium chloride salt is heated to about 500 degrees Celsius, where the salt becomes liquid and behaves as a solvent. Used fuel is placed in a basket and immersed in the salt, where it acts as the anode. An electric current is then applied to form an electrochemical cell, with the useful materials drawn to the cathode where they are deposited, collected, and prepared for reuse. Once recycled, the fuel heads back to the reactor once again, while the 4% fission product is encapsulated in glass for safe storage. Since pyroprocessing allows used fuel to be recycled, it makes nuclear less reliant on the continuous mining of natural uranium, becoming a highly sustainable solution, as well as one that protects our environment and our health. Some researchers say introducing pyroprocessing to the nuclear energy production cycle presents a more environmentally responsible, efficient, and cost-effective source of energy than anything we have today. What do you think?